Okay, here comes a really mathy physics lesson. You'll love this. I'm just going to make sure I got my screen as big as I can get it. That's probably good enough. So here we're looking at acceleration, and we're going to be calculating accelerations. But first, understanding what it is. Well, you know, the technical definition is rate of change of velocity. You might remember that rate of change refers to a slope. And we talked about that yesterday in like the last lesson with the velocity time graphs. That the slope of a velocity time graph is acceleration. Okay? I think, you know, from a principles point of view, to me what acceleration is how fast an object speeds up, slows down, or changes direction. Here's the equation. Okay? It's the amount of time we're talking about, and v2 minus v1 means the change in velocity, which again, if you're looking at rate of change or slope, this just means it's a slope, because if I go from this time to this time, then the time, you just read it off the graph, right? And then you've got the rise would be v2 minus v1. The run would be how much time was covered over, and the rise is v2 minus v1. So that's all it is. We won't really be looking at it in terms of slope from our point of view, but that's how you calculate it. There's the equation for it. And the units are meters per second per second. And the reason that's true, of course, is because, you know, you've got meters per second on top. This is going to be really messy, but meters per second on top here divided by second, right? Because time is in seconds. Hey, come here. Uh-oh. Uh-oh. Feels like my computer's going to freak out. Anyways, so it's meters per second, which translate into meters per second squared. Okay? So the symbol is A, obviously, or maybe not obviously, but that's what it is. There's the equation, and there's the units. If I was going to take that equation, because this will happen a lot in the course, is you've got to write, maybe you're given a question and you know acceleration, and you know v2, and you know time, and you're looking for initial velocity. Very common thing. Well, that's when you'd use one of these equations. This is all the same equation, but it's just written rearranged. Okay? And I'm not going to spend time rearranging the equations for you. This is, or like with you, this is what they are. So when you have your formula sheet, you can write these out. If you're really good at rearranging, you only really need this one, and you can figure out the rest. But if you're not, some things to be aware of, what is what. V2 means final velocity, and the units have to be meters per second. They don't have to be, like it could be kilometers per hour, but then if you've got time in seconds, then your units for acceleration become kilometers per hour per second, which is theoretically fine, but we're never going to do that. I would like you every single time to, if you're given kilometers per hour, change it to meters per second and report your accelerations in meters per second squared, which means that velocities are always meters per second, time is always seconds. Okay? But anyways, we're going to use these formulas a little bit. So, always these end up being in some kind of application, some sort of word problem. So Ferg's driving a Mimos. As he hits the highway, he's at 10 meters per second, but he accelerates to 40 meters per second within 5.5 seconds. So what's his acceleration? If it takes him 5.5 seconds to go from 10 to 40. So I wanted to write this out. I wrote it out on all the questions because something I do score you on is your communication, and I think communication helps you be a better problem solver. So it's important to me that you do this. So the first is that you list the givens with the units. So, you know, here we go. I'm given V1, V2, and time. So I'm given 10 meters per second. That's his first speed or velocity. There's his second velocity, and 5.5 seconds must be time, right? I'm looking for acceleration. So when you list your givens, it's also good to write down what you're looking for, because this will help you later on when you see the stuff we do tomorrow, okay? So in this question then, so the next thing you would do is you'd write down, okay, there's the formula I'm going to use. I don't have to think too hard because I'm only showing you one formula. It can't be anything else. We're going to take the symbols, like the V2 and V1, I'm going to substitute in numbers. So you don't have to put the units and all that stuff. And you'll also notice, by the way, when we get into solving these questions, I get lazy about the vector symbols. We'll put them in at the end, okay? But for now. And you end up with, there's my vector symbol at the end. So substitute numbers in the formula, obviously calculate it. So 40 minus 10 over 5.5 gives you 5.5. And you're going to write down the answer with units. Remember I said acceleration is meters per second squared. And then circle, so this is my circle, the answer, and check mark it. And you're thinking, okay, what does she mean? Doesn't mean you're right. But something I think is important in physics, because it's not math class. Physics, everything has a reason, everything has a purpose, every number means something. We don't know good accelerations because we're just learning accelerations, but I'm going to tell you that if you have an acceleration, you're doing a regular calculation, it's a regular object on a bike or on feet or in a car, then accelerations tend to be between minus 10 and 10. There are certainly, you can have accelerations outside of that range, but then it's something different. It's not just a car. It's going to be like a rocket ship or some non-practical application. So I like to see students check mark their answers, and what that means to me is you've sort of not just plugged numbers into your calculator, but you've thought, does my number make sense? Okay, this is physics, it's not math. The numbers have a meaning, and does within the context of the question, does the answer make sense? And so, yes, check mark it. And then the other thing is just to make sure that if the question's using, in this case, 0 or 1 decimal places, your final answer should have 0 or 1 decimal places. Right? There's one exception to that I'll talk about later in the course, but most of the time that's true. Okay, let's try another example. First, sees the stop sign and hits the brakes. So he's initially 75 kilometers per hour north. By the way, kilometers per hour, I'm telling you that means we're going to have to change it to meters per second. And he slows to a stop in 3.5 seconds. What's his acceleration? A couple things to think about. What does the north mean, right? Sometimes, sometimes this would be a case where you'd have to, and I didn't actually do it because we didn't have a second speed, but say I might write down here north positive. That's a good thing. There it is. A good thing to start with, because I'm going to say that V1 is just positive 75 kilometers per hour. I'm not going to bother writing north anymore. And I got to get into meters per second, so you divide by 3.6. Again, if you're not sure about that, you can use the Google converter. So I've listed down my givens. There's all my other givens. We're looking for acceleration. Okay. So I've done this step list givens. Let's write down the formula. You'll notice everything here is the same as the last page. So if you're writing this out, you might not want to write it out again. There's our formula. Again, not a lot of choice there so far. Soon you'll have to choose your formula, which I say makes it harder, but for now, write in the given. So we know V2 is 0. Oh, just by the way, slows to a stop, right? Slows to a stop, so V2 is 0. T is 3.5 seconds, and of course we're looking for A. And you work that out. This time, because I'm going 0 minus 20.8, I've got a negative number, which kind of makes sense because he's slowing down, right? So generally means, I don't know, a few spelling errors there. Negative acceleration generally means slowing down. But it could also mean speeding up in the negative direction. And you might remember that from, I don't know, one of the last, when we talk about graphs somewhere. So the answer could be minus 5.8, and that's probably how I would leave it. And by the way, I'm going to check mark that. I've circled it. Check marked it because, again, minus 10 to 10 is my frame of reference. Okay. Or it could be, I could also just call it 5.8 meters per second squared south. Both of them are correct. Which seems weird because he's slowing down, he's not speeding up, but he's still accelerating in the south direction. He's moving north, accelerating south. Okay, I got one more example for you. Ferd accelerates on his bicycle. So we're given an acceleration. He's starting at 5 meters per second, and he's given a time for 6.5 seconds. How fast will he end up going? So in this case, write out the givens. It's V2, I don't know. Okay, so that's why I think it's good to write out your formulas, like write out what you're given, and then write out what you're looking for. How fast will he end up going? That's got to be V2. Okay, because then you can go back to this page and choose this formula. Because I'm not looking for A, I'm looking for V2, so I'll use that formula, which is the same formula, just rearranged. Okay, so V2 is V1 plus AT, sub in the numbers, get an answer, stick the vector symbol on it. Correct number of decimal places, I chose 1, because there's 1 in the question. Circled it, and does that number make sense? So what is he doing? 20 meters per second sounds fast. On a bicycle, sounds very fast. Put that in context. What's that in kilometers per hour? Well, I'm not going to multiply it by 3.6 in my head, but I can multiply it by 4 in my head. 80 kilometers per hour is fast. However, if you're if you're an awesome cyclist and you're going downhill, you can peak out around 80. So even though it's a big number, it's a possible number, and within the context of the question, it seems to make sense. Okay, I don't see where I could have made an error there. So where I might not check mark that is, what if I'd gotten 75 meters per second? Okay, if I got 75 meters per second, then either you can say to yourself, either Miss Stone wrote a bad question, which happens, or you made a calculation error somewhere, right? But in this case, I think that's about right. It's fast, but it's still possible. Okay, that's it. That's acceleration. So you got some work to do with respect to that.